नहीं चलो another question. Students, all of you can hear me? Ayushman, Ayushi, SKG Padi, Muskan Gupta, IS channel, Rohit Gayakwad, how are you? Students, this is a very, very important live session because I just explained you in a live session chemical bonding. Shivanshu, how are you? Mohammad Shamshad, how are you? Amit Yadav, how are you? Who else is there? Harsh Gaikwad, Sufia Saraf. Chemical bonding students, without chemical bonding, say bye-bye to 15 questions of inorganic chemistry. If you don't know structure of atom, periodic table and chemical bonding very well, you would not do good in inorganic chemistry. You would feel everything has to be remembered, but the concepts are actually in chemical bonding chapter. Ratul Chaudhary, how are you? Astha Sinha, how are you? Rashi Srivastava from Madhepura, how are you? Sumit, how are you? Ankit Raj, kya haal hai? Akash Namdev, how are you? Guys, so all of you are ready to study chemical bonding from Anupam sir. How many of you have watched the videos of Anupam sir? Abhishek Tiwari, how are you? How many of you have watched videos of Anupam sir in chemical bonding? Suchata Das, how are you? I have a question. Akash, you have my number. Call me after this live session, 9665 I am not able to understand your question, so we will not waste other people's time. Bezuban Ishq, what is the name? Awesome. Aarti Divya, how are you? So you are ready to start, students? Should we start? Should I call Anupam sir? Should I call Anupam sir? I want promise from all of you. You are going to practice these problems with Anupam sir. Try and understand concepts and take out a notebook and take notes properly. These questions in this notebook in which you are going to write, these are the questions from which you will revise before your NEET exam. So it is extremely important that you make proper notes out of this live session. Karthik Babu, how are you? So this live session is going to be in English, but most of you are modern Indians. You are a combination of Hindi and English. So going from English to pure English is not difficult for you. And as you can see on English channel, there are a lot of videos of different faculties, great quality videos, but this is an extremely important chapter, extremely important, and a lot of you will face difficulty in this chapter. So this is why we are going to do two live sessions, one today and one next Sunday at 6 p.m. So listen to Anupam sir very carefully for next 2 hours. No chit chat, extreme focus, take notes in your notebook and make sure you take full benefit out of it. I am giving it to Anupam sir, 1 minute. Students, just 1 minute, Anupam sir will come in front of you. Just 1 minute. All right, sir.
टेस्ट पेपर के रिजल्ट हो गए?
It should be there. But I have taken promise from all of these students. This is an extremely important chapter.
Yeah.
So they are going to take proper notes, sir. And they are not going to go anywhere till the time this is complete. This live session and next Sunday live session. You said we should have 2 live sessions in chemical bonding. Sir, one thing I want to know from you. Till where are we going to cover in this live session?
Up to LDS, Lewis dot structure.
So I want to write down the topics, sir. Which are the topics we are covering?
Ionic bond complete.
Ionic bonding, okay.
And polarization of ions.
Polarization of ions.
And LDS.
Lewis dot structure.
Of covalent species. Yahi.
Lewis dot structures of covalent species.
Yeah.
And sir, what are we going to cover in the next live session?
Remaining.
Remaining is what, sir? Next.
Hybridization.
Hybridization.
And MOT.
MOT, molecular orbital theory
Yeah, and structure and shape.
of molecules,
Yeah.
of shape of molecules and compounds. Okay.
That's it. And weak forces, hydrogen bond.
Hydrogen bond and dipole moment, etc.
Yeah.
Hydrogen bond, dipole moment, etc. This we will cover in next Sunday. So student, this next Sunday and this we are doing right now. Sir, I will rub this and then we can start. So students, say good evening to Anupam sir. Take his blessings. If he blesses you, you are going to do good in chemical bonding. Because if you have seen his videos, you will understand in what detail he has explained these videos.
Okay. Hello students. Yeah, I am fine. Okay. Let us start. Let us start.
Yes, sir.
Everything is fine?
Yes, sir.
Okay. The first question is, the linear structure is not assumed by. Listen. The first option here is SnCl2. You have read the rule to find hybridization of the central atom. And what is the rule? First find N. N is what here? N is number of sum of valence electrons of all the atoms. So look, valence electron of Cl is 7. So 7 2 ja 14 plus, and since tin is in carbon family, so the valence electron of tin is same as that of carbon, that is 4. So here N becomes 18, that is sum of valence electrons of all the atoms, that is N is 18. Now what is to be done here? Divide 18 by 8. 8 2 ja 16, so quotient here 2 and remainder is 2. Remainder 2 means central atom has 2 non-bonding electron, and 2 non-bonding means 1 lone pair, and quotient is 2 means central atom has 2 sigma bonds. So here you can see steric number of central atom tin is, steric number is equal to Q plus R by 2. So steric number will become here 3, and steric number of central atom is 3. That means 3 orbitals of it will participate in hybridization, and 3 orbitals means 1s and 2p. So here the hybridization of tin will be sp2. sp2, but it has 1 lone pair. So sp2, you know, it is its electronic geometry is trigonal planar, but 1 hybrid orbital has lone pair, and as you know, lone pair does not determine the shape of the molecule. So forget this. So this is bent. This is bent or angular, not linear, because here is 1 lone pair, and as you know, the repulsion between lone pair and bond pair is more than the repulsion between bond pair and bond pair. So bond angle here is lesser than 120 degree as well. So this is not linear, this is bent. I hope everyone got. But other options like NCO minus and NO plus and NO2 plus, here hybridization of N is sp. You can find this by using such a rule, and NO plus is also sp here. Sp means linear, and this is also sp, so linear. Okay. Harshika Pandey, Sivanshu, hello, good evening. Ayushman Moria, Pujita, good evening, very good evening. Now, the next question is, which of the following does not conduct electricity in the fused state? Fused state means molten state. And as you know, ionic compounds conduct electricity in fused state because ionic compounds consist of ions, and in molten state ions get separated, ions get free, and these free ions conduct electricity. So, does not here it has been asked does not conduct electricity. So, here answer will be BeCl2 because BeCl2 is not ionic, this is covalent, because here you can see Be2 plus, beryllium has 2 plus charge and its size is very small. So, the charge density of Be2 plus is very high, and since its charge density is very high, so its polarization power is very high, and as you know, more the polarization power of the cation, more will be the covalent character in its compound. So, due to very high polarization power of Be2 plus, BeCl2 becomes covalent due to polarization, much polarization in it, and since it becomes covalent, and you know covalent compounds consist of molecules, and molecules do not conduct electricity. It is not ionic compound, it is covalent. But MgCl2, SrCl2 and BaCl2, these are ionic compounds. So these these consist of ions in fused state. Ions will get free, and these free ions will carry the charge, right? Okay. Now the third question is, which of the following hydrides is not ionic? Listen, first is calcium hydride. Calcium is an alkaline earth metal. It is a very reactive metal, and therefore hydride of calcium, that is CH2, is an ionic compound. BaH2, barium, is more electropositive than calcium, alkaline earth metal. Its hydride is ionic. Strontium hydride, it is also ionic, but BeH2 is not ionic hydride. This is covalent hydride due to very high polarization power of Be2 plus. Due to very high polarization in it, covalent character predominates here, and BeH2 becomes covalent and it has polymeric structure. BeH2 is covalent and it has polymeric structure, so answer will be 4. Now, the next question is, carbonate anion does not has which of the following characteristics? You know, carbonate, as I had said earlier, carbonate, that is carbon has suffix 8. So add oxygen to carbon, and as you know, symbol of carbon is C and its valence electron is 4. And how will you arrange 4 electrons to make the radical? To 2, 1, 1. Now add oxygen with 2 electron, 1 oxygen, no charge will appear. With 1 electron, 1 oxygen, 1 negative. With 1 electron, 1 oxygen, 1 negative. So carbonate is this, and its structure is, this is carbonate, and here you can see the negative charge, that is the lone pair, is in conjugation with the double bond. So there will be the resonance, and it will have 3 resonating structures, and the 3 resonating structures of it are equivalent, are equally contributing. Therefore its real picture can be given by a hypothetical structure of it called resonance hybrid. And in its resonance hybrid, there will be sigma bond in between C and O, and one pi bond will be equally distributed in between all the three sigma bonds, right? Total 2 negative. So here you can see all in resonance hybrid of carbonate, all CO bond order is same. All CO bond order is same, so all CO bond lengths will be same, all CO bond energies will be same, all bond angles will be same. And here hybridization of carbon will be sp2. Now look the question. The question is, carbonate anion does not has which of the following characteristics? First is bonds of unequal length. No, this is wrong. I have to choose does not has. So bonds of unequal length, this will be the answer here, because we have to choose does not has. But as you know, in the resonance hybrid of carbonate, all CO bond order is same, so all CO bond length will be same. And here in option 1 it is written bonds of unequal length, so this is does not has which of the following. This is not the characteristic of carbonate, and it has been asked, therefore its answer will be 1 1 1 1. And sp2 hybridization of carbon atom, yeah, because here you can see carbon has 3 sigma bonds and 1 pi bond. As you know, pi bond does not involve in hybridization, so only 3 sigma bonds, and 3 sigma bonds mean 3 orbitals of it will participate in hybridization, and 3 orbitals means 1s 2p. So here the hybridization of carbon is sp2. Resonance stabilization, yeah, here you can see negative charge is in conjugation with the double bond, so negative charge will get stabilized by resonance, because due to resonance negative charge dispersed over all the 3 O atoms, and so due to resonance negative charge density is decreased, and so stability increases, right? And same bond angles, yeah, this is true, all bond order same, so all bond angles, bond length same, so its answer will be 1. Okay, right? Ratul Chaudhary 1, Smridhi Verma 1, Madhu Mehta 1, Mohammad Asraf, good evening, good evening. Rasi, sir, what is resonance stabilization? Yes, resonance stabilization. Listen, if negative charge is there on an atom, then to make it stable, the negative charge will tend to decrease its density. And how can it decrease its density? By dispersing the negative charge over all the molecule. By dispersing the negative charge by resonance, negative charge density will decrease, and so stability will increase. And resonance in detail will study it in organic and in inorganic further. Now the next question is, which of the following process is not associated with change of hybridization of the underlined compound? Right, does not change in the hybridization of the underlined compound. First is AlOH whole thrice. Here you can see AlOH, this is AlOH. Al has 3 sigma bonds here, and so 3 sigma bonds means 3 orbitals of it will participate in its hybridization. So here hybridization of Al is sp2. Now this precipitate of aluminum hydroxide is dissolved in NaOH, right? As you know, aluminum is an amphoteric metal. So aluminum hydroxide is amphoteric. And as you know, amphoteric substance dissolves in acid as well as in alkalis. NaOH is a strong alkali and this is amphoteric, so it will dissolve here. Here you can see Na has +1 charge, so OH will have minus. This is aqueous NaOH, so it will be in ionic form like Na plus and OH minus. And Al has one vacant 3p orbital. To complete its octet, it will tend to accept one lone pair. So OH minus will donate its lone pair to the vacant 3p orbital of aluminum like this and will form coordinate bond. If you write covalent bond in place of coordinate bond, then negative charge will develop here. So it will become Al OH whole 4 minus and this Na plus. So this becomes Na plus and Al OH whole 4 minus. Now in this complex anion, in this anionic part, you can see Al has 4 sigma bonds, and 4 sigma bonds means 4 orbitals of it will participate in hybridization, and 4 orbitals means 1s and 3p. So here the hybridization of aluminum will be sp3. So here the underlined atom here is Al and its hybridization has been changed. So this will not be the answer. We have to select where there is no change in hybridization of the underlined compound. Okay. Now B2S6, this is diborane, and in diborane hybridization of boron is sp3. Actually diborane is the dimer of BH3. This is banana bond. You will study it in later part of chemical bonding. And hybridization of each boron here is sp3. Now B2S6 is dissolved in THF. THF, full form of THF is tetrahydrofuran. Tetrahydrofuran is this. You may look here. This is tetrahydrofuran and O has 2 lone pair. So it can donate its lone pair. This is THF and O has 2 lone pair. It can donate its lone pair. So this will act as Lewis base. And diborane first dissociate into its monomer BH3 and B has vacant 2p orbital. It can accept lone pair and can form a coordinate bond with Lewis base. So this will donate its lone pair to its vacant 2p orbital and will form coordinate bond. Now you can see here B has 3 sigma bond with 3H and 1 coordinate bond. That is here B has 4 bonds, 4 sigma bonds, single coordinate bond acts as sigma bond, 4 sigma bonds. So here also hybridization of B is sp3 and in diborane also hybridization of B is sp3. This is a adduct like this. This is THF and this is diborane. Diborane will first break into its monomer BH3 and this is Lewis base. BH3 is Lewis acid, so will form coordinate bond here and still here hybridization of boron is sp3. Here also sp3. So no change in hybridization of the underlined atom here. Here underlined atom is B. It is obvious here. Now the third part of this question is SiF4 and this is passed through liquid HF. You know the maximum covalency of silicon is 6. So 2F minus will form coordinate bond with vacant d orbital of silicon, and 2F minus have been added to SiF4. So 2 negative charge will develop here. 2 negative means here 2H plus will come. Now you can see here silicon has 4 sigma bonds, so hybridization will be sp3, but here silicon has 6 sigma bonds, so 6 orbitals of it will participate in its hybridization, and 6 orbitals mean 1s, 3p and 2d, and so here the hybridization of silicon is sp3d2. So here hybridization of underlined, I mean central atom, has been changed. Okay. Scroll the question. Right, now it is okay. It is okay. And the fourth point here is solidification of PCl5 vapor. Look here. PCl5 in gas phase is in molecular form, but in solid state, in crystalline state, PCl5 undergoes partial ionization into PCl4 plus and PCl6 minus, and in PCl4 plus hybridization of P will be sp3, and in PCl6 minus hybridization of P will be sp3d2. But in molecular form, in gas phase, hybridization of P in PCl5 will be sp3d. So hybridization has been changed here. So its answer will be 2. Any doubt to anyone? Next, question number 6. Next, move to the next question. Question number 6. Question number 6. Now you can see which of the following statements are not correct. Which of the following statements are not correct? Option 1 is all CO bonds in carbonate are equal. Yeah, this statement is true here, because in carbonate the 3 resonating structures are equivalent, and therefore in the resonance hybrid of carbonate all CO bond order will be same, and so all CO bonds will be same in carbonate, but not in H2CO3. H2CO3, this is carbonic acid. H2CO3 is, look here, H2CO3. Its structure is this. This is H2CO3. Here O has a lone pair. If this lone pair is in conjugation with the double bond, agree? So this lone pair may undergo resonance, but if this lone pair will form pi bond here, plus charge will develop on O, and plus charge on O is highly unstable, and therefore you will say no resonance will take place here. That is, here the resonating structure will be so less stable that you will consider it no resonance will take place here. And if no resonance will take place, then this CO bond and this CO bond will be similar, and this CO bond will be different, because this CO bond is a double bond, so it will be smaller, and this is single bond, so this will be longer. So different CO bonds will be here in H2CO3. So this is correct. We have to choose not correct. In option 2, you can see all CO bonds in HCO2 minus are equal. HCO2 minus, HCO2 minus, this is formate ion, C double bond O, O minus, and this is a formate ion, HCO2 minus, and you can see here O has a negative charge, so lone pair, 3 lone pair here on O, and this lone pair is in conjugation with the double bond, so resonance will take place here to stabilize negative charge, so that the negative charge should get dispersed over both O, and negative charge density should decrease to make it stable. So due to resonance, its both resonating structure will be equally contributing, and therefore in its resonance hybrid, this pi bond will get equally distributed in between both CO bonds, and therefore in formate HCO2 minus, both CO bond order, bond length will become the same. So this point is right, but not equal in HCO2H. HCO2H. This is formic acid, and here O has a lone pair. This lone pair is in conjugation with the double bond, but if this lone pair will form pi bond here, O will have plus charge, and plus charge on O is not stable, so you will consider that no resonance will take place in this. And since no resonance, therefore this CO bond and this CO bond will be different, because this is double bond, this is single bond, and both CO bond will be different here. And this point is also right. Now the third option is CO bond length in formate is longer than CO bond length in carbonate. Look here. In formate, HCO2 minus CO bond order will be what? CO bond order will be what? You can see there is one sigma bond in both CO bond, and the pi bond, one pi bond will equally be distributed in between both sigma bond. So in resonance hybrid of it, half pi bond will be with this sigma bond, and half pi bond will come with this sigma bond. So in the resonance hybrid of it, each CO bond has one sigma bond and half pi bond. So in HCO2 minus, CO bond order will be 1.5. But in carbonate, this is carbonate, CO bond order will be what? 1 plus pi upon sigma. You know the formula. Pi is 1 and sigma 3. So 1.33. So you can see here, in formate ion, CO bond order is more than that of carbonate, and more bond order than a smaller, shorter bond length. In carbonate, CO bond order is lesser, so greater bond CO bond length will be in carbonate. And here it is written CO bond length in formate is longer than CO bond length in carbonate. This is wrong, because in formate you can see CO bond order is 1.5, and in carbonate CO bond order is 1.33. Therefore, in carbonate, CO bond order is smaller, so CO bond length will be longer in carbonate. This is wrong. So, in question number 6, answer will be 3. Aluminium is sp2 hybridized because of 3 sigma bonds. Yes, correct. Now, in the recorded videos, I have discussed a rule to find hybridization of central atom, and watch that video, you will get it. Now, question number, next. Question number 7. In this question, the electronic configuration of 4 elements P, Q, R are given. एक तो छूट गया, L होगा ना, अच्छा L इधर to this side. Okay, got. There are 4 elements L, P, Q and R, and you can see valencies of these elements. Look here, L 1s2, 2s2, 2p4. So it is oxygen, you know, valence total electron 8, it is oxygen. 2p4, so to complete its octet, it will gain 2 electron, and therefore valency of L is 2. This is oxygen. Now P 1s2, 2s2, 2p6, 3s1. Its valence electron is 1. This is sodium, so it will lose 1 electron to complete its octet, and therefore valency of P will be 1. Now Q 1s2, 2s2, 2p6, 3s2, 3p5. This is chlorine. 17 chlorine, 3p5. It will gain 1 electron to complete its octet, and therefore valency of Q, that is Cl, is 1. And R 1s2, 2s2, 2p6, 3s2. Its valence electron is 2. It is magnesium, atomic number 12, and 3s2. Its valence electron is 2. Therefore, it will lose 2 electrons to complete its octet, and therefore its valency is 2. Now, the formula of ionic compounds that can be formed between these elements are P and L. P and L, and P, its valency 1, L, its valency 2. So valency of L will be given with P, and valency of P is 1, so here 1, so P2L. P2L, this is right. In between RL, valency of R is 2 and valency of L is also 2. 2 will be cancelled out, so simple ratio will be 1:1. So RL, so its valency will be, its formula will be RL. Valency of R is 2, valency of L is also 2. Simple ratio 1:1. Next, PQ. Valency of P is 1 and valency of Q is also 1. So, formula of the compound formed by P and Q will be PQ and RQ. Valency of Q is 1, valency of R is 2, R is metal here, so first write metal, then non-metal Q, and its valency of R is 2, so give here 2, and valency of Q is 1, so give here 1, so RQ2. So its option is 3. Mohit Panigrahi. Because we don't calculate pi bond in hybridization. Pi bond has nothing to do with the hybridization. In hybridization, sigma bonds with the central atom and number of lone pair with the central atom is calculated. Now the next question, question number 7 ke after 7, question number 8. Question number 8 is lattice energy of an ionic compound depends on. This has been discussed in video lecture, and mode of lattice energy, that is value of lattice energy, is proportional to charge of cation into charge of anion upon interionic distance, right? So lattice energy of an ionic compound will depend on charge of cation, charge of anion, and size of the ion also. So charge on the ion only, this is wrong. Size of the ion only, this is also wrong. Packing of ions only, this is wrong. Lattice energy, value of lattice energy depends on all these three factors like charge, size, as well as on packing. Packing means how closely ions are packed in the crystal lattice. So packing of ions only, this is wrong statement. But fourth option is charge on the ion and size of the ion, this is right. So its answer will be 4. Which is longest bond, single or double? Obviously single bond will be longer than double bond, and triple bond will be smaller than double bond. As bond order will increase, bond length will decrease. Okay. Now the next question, question number 9. Question number 9. Many ionic crystals dissolve in water because water is an amphiprotic solvent. Yeah, this is true, but this is not the reason of that ionic crystals dissolve in water. We have to find the reason of this. So water is an amphiprotic solvent, this is right statement, but this is not the reason of the question. So this will not the answer. Water is a high boiling liquid. Yeah, this is true, but not this is the answer of this question. The process is accompanied by a positive heat of solution. This is not true, because if heat of solution is positive enough, then salt will not dissolve in water. These things have been discussed in detail in your video lecture. So watch video lecture carefully. And fourth option is water decreases the interionic attraction in the crystal lattice due to salvation. This should be solvation, right? This is the right answer, because look here, as you know, an ionic compound has lattice structure, definite crystalline structure, in which generally anions form the lattice, that is packing, and cations occupy the voids. But when ionic compound is added to water, cations and anions get hydrated, that is get solvated with water, and due to solvation of ion, the attraction between cation and anion decrease, because suppose this is cation, and due to hydration, that is solvation by water, water molecule makes an envelope over it. Similarly, anion gets solvated by water, and water makes a layer, that is an envelope over it, and due to this envelope of water over the ion, the charge of the cation and anion gets shielded, and so the attraction between cation and anion decreases. And due to decrease in the attraction between cation and anion, ions leave their crystal lattice site and get solvated, get free, get hydrated, and that's why ionic compounds dissolve in water. So question 9, answer 4. Okay. Next question number, how you calculated the bond order of HCO2 minus? Ankit, look once again. HCO2 minus, this is format ion, and this structure is HC double bond O and O minus, right? Now, it will have two resonating structure. One is this. In other resonating structure, this lone pair will make pi bond here, and this pi electron will come here. So, its resonating structure will become like this. Okay. Now you can see its both resonating structures are equally contributing. Therefore, its actual picture will be represented by its resonance hybrid, and in its resonance hybrid you can see there is a sigma bond in between both CO bond, but one pi bond will equally be distributed in between both CO bonds. So because both resonating structures are equally contributing, so half pi bond will remain with this sigma bond, and half pi bond will come with this sigma bond in the resonance hybrid. So in the resonance hybrid, half pi bond here and half pi bond here. So in the resonance hybrid of it, you can see each CO bond has one sigma bond and half pi bond. Here also one sigma bond and half pi bond. So CO bond order here will be 1.5. One sigma, half pi bond with each CO bond. So CO bond order here 1.5. Another formula is to find the bond order, CO bond order whatever it be, 1 plus pi upon sigma. 1 plus pi bond is 1, and here sigma bond you will take only 2, this sigma and this sigma only. Don't take this sigma because no pi bond will form to this side, because H can form only one bond, not double bond or pi bond like that. So this sigma and this sigma, 1 plus 1 by 2, that is 1.5. In this way you can find the CO bond order in format HCO2 minus, right? Okay. Now the next question, question number 11, right?
Yes, sir.
Question number 10 has been done. 10 has been done. No. 10. Question number 10. Move to question number 10. This is favorable conditions for electrovalency. Electrovalency means for the formation of electrovalent bond, that is more ionic character in the compound. That is for the formation of ionic compound, electrovalent compound. That means electrovalency. Electrovalency means electrovalent bond, that is electrovalent compound or ionic compound. Conditions for the formation of ionic compound, more ionic character in the compound. That means, okay, low charge on ions, large cation and a small anion. This is right, because listen, for more ionic character in the compound, that is more electrovalency in the compound, the polarization power of cation should be least and polarizability of the anion should be least, and therefore, and for less polarization power of cation, the cation should be larger in size and should have a small positive charge, that is low charge on ions. Large cation will have less polarization power, and a small anion has less polarizability, right? Large cation has less polarization power and a small anion has less polarizability, and less polarization power of cation and less polarizability of anion, less polarization will take place in the compound, and less polarization means less covalent character in the compound, that is more ionic character in that compound, that is more electrovalency in that compound. This topic has been discussed in the topic polarization of ions, that is Fajon's rule, in detail. So watch the video properly. Rajendra Saini, sir, what is the difference between valency and covalency? Listen, valency is a general term. Valency means the number of electrons lost or gained or shared by an atom in order to acquire its nearest inert gas configuration or to make its configuration stable. That is valency. But electrovalency means in the formation of electrovalent bond, the number of electrons lost or gained by an atom in the formation of electrovalent bond, then such valency will be called electrovalency. But in the formation of covalent bond, the number of electrons shared by an atom, then the number of electrons shared by an atom in the formation of covalent bond, then here valency will be called covalency. Okay. Now, oxidation number in covalent molecule is the hypothetical charge. In covalent compound, oxidation number or atom of an atom is not its real charge. It is its hypothetical charge. Hypothetical means if in covalent bond you consider that the covalent bond undergoes hydrolytic fission, then the charge that will develop on the atom after the hydrolytic fission of the covalent bond, then that charge will be the called oxidation number of that atom. These things have been discussed in video lecture. Watch it carefully. Now the next question is question number 11. Question number 11. Move to question number 11. Question number 11 is chemical formula for calcium pyrophosphate is Ca2P2O7. Look here, you know oxidation state of calcium will always be +2 in any compound. Calcium has valence electron 2, so it will lose 2 electrons. So always in any compound, oxidation state of calcium will be +2. Oxidation state of calcium is +2 and 2 calcium atoms here. So +2 into 2 +4. That is both calcium. Total plus charge is +4. So the anionic part here must have 4 minus. So here the anionic part is P2O7 and it must have 4 negative charge, and this is called pyrophosphate. Its valency will be 4. Now you have to write the formula of ferric pyrophosphate. Ferric. In ferric. If I say ferric, then you will take valency of iron 3. If it is written ferrous, in ferrous valency of Fe will be 2, and in ferric valency of Fe will be 3. So this is ferric valency 3 and pyrophosphate is P2O7, its valency is 4, crisscross. So valency of Fe 3 and its valency will come with pyrophosphate, so whole thrice here, and valency of pyrophosphate 4 will come with Fe. So formula of ferric pyrophosphate will become Fe4 P2O7 whole thrice, and therefore the right answer will be 3. Okay, 3. Right. Now question number 12. Move to question number 12. 12. Which of the following has highest melting point? Listen. Remember, ionic character proportional to melting point. That is, more the ionic character in the compound, higher will be the MP of that compound generally. Generally, why? Because melting point also depends on the packing of the ions, and therefore there are many exceptions in MP, and no regular trend of MP is found. So I have said generally more ionic character in compound, more melting point of that compound. So here you can see BeCl2, MgCl2, CaCl2 and BaCl2. In all these compounds, anions are same, that is Cl minus. Cation, charge on cation is same, but among these, the smallest cation is Be2 plus, right? And largest cation among these is Ba2 plus. So, Ba2 plus has a large size, so less charge density, so less polarization power of cation, so less polarization will take place in BaCl2, and less polarization, so less covalent character will develop in BaCl2, and less covalent character, then more ionic character. And so among these four, BaCl2 has more ionic character, highest ionic character, so it should have highest melting point here. So its answer should be BaCl2, that is 4. 4. Viraj, explain banana bond. Banana bond has been discussed in chemical bonding part 2, and question on it will definitely come in second test of chemical bonding, and we will discuss it in next week. Okay. In this part, basically you have to focus on polarization of ions, ionic bonding, solubility, thermal stability, Born-Haber cycle, lattice energy, hydration energy, and Lewis dot structure of covalent molecular species. Right. Now, question number 13. Move to question number 13. 13 is the correct sequence of increasing covalent character is represented by increasing covalent character. Look here. NaCl, LiCl, BeCl2. Look here. Anions are same. So anions will not decide, not determining factor here. Here you can see Na plus 1, Li plus 1. Both Li and Na has same charge, but Li plus is smaller in size than Na plus, and as smaller the size of cation, more is its charge density, so more its polarization power, and more polarization power of cation, more will be the covalent character in its compound. So LiCl has more covalent character than NaCl. Now, in between LiCl and BeCl2, you can see Li has plus 1 charge and Be has plus 2 charge, and still Be2 plus has a smaller size than that of Li plus. So Be2 plus has more charge and a smaller size than Li plus, so charge density of Be2 plus will be more than that of Li plus, so more polarization power of Be2 plus, so more polarization in its compound, and so more covalent character in its compound. So the correct covalent character order will be this. Least covalent character will be in NaCl, LiCl will have more covalent character than NaCl, and BeCl2 will have more covalent character than LiCl. Now, the next question. Students, everything fine? Sir, what is delta bond? Asutosh Pandey. Delta bond has been discussed in chemical bonding part 2 in detail. Delta bond is formed by 4 lobes, 4 lobes interaction, like d orbitals, you know, d orbital, a d orbital has 4 lobes. So in between two d orbitals, 4 lobe interaction may take place and delta bond can be formed. Right? Now the next question is, move to question number 14. Question number 14. Which is the correct electron dot structure of N2O molecule? So look here. In the first part, in part 1, you may see the middle N has not completed octet. In LDS, electron dot structure, that is in Lewis dot structure, each atom must have completed octet. So its right answer will be 2. Look here. N2O, this is called nitrous oxide and commonly called laughing gas. This is called laughing gas because when it is inhaled in a small quantity, it produces a hysterical laughter. But in excess, it may prove fatal. It may cause even death. So N2O. Students, have you watched the video of LDS, rules to write LDS? How can you write the LDS of covalent molecular species? In that video, I had said to write LDS of a covalent molecular species, first of all, find N1, N2, N3 and N4. Here N1 is what? Sum of valence electrons of all atoms. Valence electron of O is 6. It's 5. 5 2s are 10 plus 6, 16. N2 is what? 2 into number of H atom. H atom is 0 here. Plus 8 into number of other atoms. Other atom 3. So 3 into 8, 24. So N3 will be N2 minus N1, 8. So number of covalent bonds will be N3 by 8, that is 8 by N3 by 2, that is 8 by 2, that is 4. And N4 is find N1 minus N3, that is 16 minus 8, 8. So number of lone pair will be N4 by 2, that is 8 by 2, that is 4. So in all its LDS, there should be 4 covalent bonds and 4 lone pair, and each atom must have completed octet. Now N, O. We have to make 4 covalent bonds. So one possibility is 3 covalent bond here and 1 here. Second is 3 covalent bond here and 1 here. And third possibility is 2 covalent bond here and 2 here. So N2O can have 3 Lewis dot structures. So one way is make 3 bond here and 1 bond here. Now this is LDS, so each atom must have completed octet. So complete the octet of each atom. As you know, valence electron of N is 5. 1, 2, 3, 4, 5. Valence electron of N is 5 and it shared 3 electrons from this N. So this N completed its octet, right? Now, valence electron of N is, this N is 5. 1, 2, 3, 4, 1 remaining, 5. Valence electron of N 5, 3 electrons shared from this N 8 and 1 electron shared from this O 9. 1 more than 8. So it will lose 1 electron to complete its octet, and therefore 1 positive charge will develop here. Now complete the octet of this O. O, valence electron of O is 6. 1 electron is here, 1, 2, 3, 4, 5, 6. Valence electron of O 6 and it shared 1 electron from here, 7. So to complete its octet, it will gain 1 electron and it will accept this electron. N released 1 electron, O will get this extra electron and so one negative charge will develop here, and you can see here each atom completed its octet. Bond, covalent bond 4, lone pair also 4. So this is the right LDS of N2O, and therefore the right answer is 2. Now question number 15. Move to question number 15. Move to question number 15. Next, the correct order of OO bond length in O2, H2O2 and ozone. Listen, O2. In O2, OO bond order is 2. Because in O2, N1, that is sum of valence electrons of atoms will be 6 2 ja 12. N2, 2 into 8, 16. So N3, N2 minus N1, that is 4. So number of covalent bonds will be 4 by 2, that is 2. 2 bond, and 2 bond will be in between 2 O atoms, so bond order will become 2. In ozone, OO bond order will be 1.5. How? Its N1 is N1 sum of valence electron 6 3s are 18, N2 8 3s are 24. So N3 will be N2 minus N1 6, N3 equal to 6. So number of covalent bonds N3 by 2, that is 6 by 2, 3. 3 bond OO. Now 2 sigma, so 1 will be pi. It will have 2 resonating structure. Pi bond here, pi bond can also be put here. So in resonance hybrid, there will be 1 sigma bond in between 2O and 1 pi bond will be equally distributed in between both sigma bonds. So 1 sigma half pi, 1.5. In other way, use the formula 1 plus pi upon sigma. 1 plus pi bond is 1, sigma is 2, so 1.5. So in ozone, OO bond order is 1.5. And look here, in H2O2, you know, the oxidation state of H is +1. So +1 into 2 plus 2, therefore -2 charge will appear on both O. And so here the anionic part is O2 2 minus, and O2 2 minus is called peroxide ion. This is peroxide ion. So H2O2 is called hydrogen peroxide. And in peroxide, OO bond order will be 1. How? N1, 6 2 ja 12, and it has 2 negative charge, so add 2 electrons more. 6 2 ja 12 plus 2. N1 will be 14, N2 will be 16, N3 will be 2. So number of covalent bond will be 1. So OO bond order in peroxide will be 1. Now you can see the correct order of OO bond length. As you know, bond order inversely proportional to bond length. In hydrogen peroxide, OO bond length, OO bond order is least. So in it, OO bond length will be highest. So its answer will be 3, right? Shivanshu, where did you the central carbon atoms are bonded to each other by a double bond and 2 other carbon atoms of triple bond N by single bond. The hybridization of central atoms are sp2. For what? Sunata is it is not carbon double bond N but C double bond C. So sorry, this typing mistake. Please move to question number, what was the question? Move to question number 14 or 13, 14, right, look it. This is NN triple bond. Yeah, in question number 14 there is typing error. Now it has been corrected, but in previous question it was a typing error there. So we will look it later on. Now move to question number next. Question number 16. According to Fazan's rule, covalent bond is favored by. This is a very simple question. Covalent bond will be favored by when polarization power of cation is maximum and polarizability of anion is maximum. And for maximum polarization power of cation, the cation should have a small size and high charge. And for maximum polarizability of the anion should have large size and more negative charge. Therefore, more polarization power of cation, more polarizability of anion, more will be the polarization in the compound, and so more will be the covalent character in the compound. So according to Fazan's rule, covalent bond is formed by large cation and a small anion. No, a small cation and a large anion. Yeah. So its answer will be 3, because a small cation means high charge density of cation, and so more polarization power of the cation, and large anion means more polarizability of the anion, and so more polarization, more covalent character. So answer will be 3 of question number 16. Next, 17. Sikha Misra, what explain? Please explain. Okay. Yeah. Comments are lagging. Right. Question number 17. Okay. Look here. Nitrate. And you have to write its LDS, that is Lewis dot structure. And to write LDS, what should be done first? First find N1, that is sum of valence electrons of all the atoms. Valence electron of O is 6, so 6 3s are 18 plus 5, 23, and it has one negative charge, so add one electron more, so N1 here 24. N2 will be 8 into 4 other atoms, 3 and 1, 4, 4 into 8, 32. So N3 will be N2 minus N1, that is 8. So number of covalent bonds will be N3 by 2, that is 8 by 2, 4. N4 will be N1 minus N3, that is 24 minus 18, 16. So number of lone pair will be 16 by 2, that is 8. That is in nitrate there will be 4 covalent bonds and 8 lone pair, and each atom must have completed octet in this LDS. Central atom N, O, 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 1 sigma, but we have to make 4 bonds, 3 O, 3 sigma, so you will have to give 1 pi bond. So you can give pi bond here or here or here. So it will have 3 equivalent resonating structures, and therefore its actual picture will be given by resonance hybrid, and in its resonance hybrid the 1 pi bond will be equally distributed in between all the three sigma bonds, right? Now, total charge is -1, but this -1 will be equally distributed among all these three O. So each O will have -1/3 charge in the resonance hybrid. So the right LDS will be that in which each O has -1/3. This is the real resonance hybrid of nitrate, and such type of questions have been discussed in detail in video lecture. After the topic inert pair effect, I have discussed a topic Lewis dot structure, rules to write Lewis dot structure of covalent molecular species in English medium, in pure English. So watch these topics and watch it carefully. After watching video carefully, you can do each question. Right now, move to question number 18. Question number 18. Nodal planes of pi bond in benzene are located in. This question also discussed in video lecture. Look here, benzene. This is benzene. In benzene, each carbon has sp2 hybridization because 3 sigma, 1 sigma here, 1 sigma here, and 1 sigma with H. H has not been shown here, but each carbon has one CH bond. So 3 sigma, so 3 orbitals, sp2, 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 sp2. sp2 means 1s, 1 px and 1 py. These 3 orbitals hybridize to form 3 sp2 hybrid orbital, which will form sigma bond, right? Suppose this is xy plane. That's why I have taken px and py here. Now 1 p orbital, since px and py involved in hybridization and formed hybrid orbitals which form sigma bond. But pz is unhybridized here. pz is not taking part in hybridization here. So pz will undergo lateral overlapping to form pi bond. So suppose this is xy plane, suppose this is xy plane, and here all CH bonds are in this xy plane. So now the pz orbital will be perpendicular to this xy plane. Suppose this one lobe of pz above the xy plane and one lobe of the pi bond below the xy plane. So two lobe overlapping will give pi bond. Now since the lobes of pi bond are above the xy plane, therefore nodal plane of the pi bond will come into the xy plane, which is the molecular plane here. So a pi bond pz, suppose one pz above the plane and one pz below the plane, one pz above the plane, one pz below the plane, this will form pi bond, and in between electron wave, suppose this is plus plus minus minus, in between plus minus there will come nodal plane which will come in the molecular plane. This has been discussed in detail in the topic valence bond theory in video lecture, and to do such questions smartly and clearly, you must watch that video of valence bond theory in pure English medium video, because without watching that video you can't solve such type of problem. hybridization of C2CN4. Shivanshu, you have asked hybridization C2CN4, right? Listen, what is this? You know ethene, ethylene. This is ethylene. If you give H here, this will become ethylene. Now here you have to replace all 4H by CN, cyanide. This is CN, this is cyanide, okay? And here you can see this carbon has 3 sigma 1 pi. Pi bond does not involve in hybridization. So this carbon has 3 sigma, so 3 orbitals of it will participate in hybridization. So sp2, sp2. But this carbon has 2 sigma bonds only, 2 pi. Pi bonds do not take part in hybridization. So this carbon has 2 sigma bond only. So 2 orbitals of it will participate in hybridization. Therefore, these 4 carbon atoms are sp hybridized, and these 2 carbon atoms are sp2 hybridized. So here the hybridization of carbon in this molecule will be both sp2 as well as sp. Okay? Shivanshu, it is right? Okay, now move to the next question. Okay, now move to the next question. Question number 19. Which of the following has fractional bond order? Look, such type of questions can also be solved by MOT, molecular orbital theory. But in this chemical bonding part 1, MOT has not been included. Therefore, here this time I will solve this question by LDS rule. So, by LDS rule, which of the following has fractional bond order? So, here you can see H2 plus, and in LDS rule N1, first find N1, valence electron of H is 1. So 1 into 2, 2, and since it has 1 plus, so remove 1, so N1 is 1. N2 will be 2 into number of H atom. 2 into number of H atom, that is 2 into 2, 4. N2 minus N1, 4 minus 1, 3, so bond 3 by 2. But in H2 plus, it will actually be cleared by MOT. And by molecular orbital theory, you can see here bond order is half, because for it no need of any formula. Formula will not fit here, because H2 has only 1 electron. In H2 plus there is only 1 electron, and 1 electron means half bond, because 2 electrons make 1 covalent bond, but here there is 1 electron only, so it will make half bond, and half bond means fractional bond order, half is fraction. So question number 19, answer 4. Any doubt to anyone? Okay, next question number 20. Which of the following option with respect to increasing bond order is correct? Look here, this question can also be solved by MOT. Actually, such type of question should be solved by MOT, but here you will solve such problems by using LDS rule. And in LDS rule, for NO, you can see here for NO, N1, that is valence electron, sum of valence electrons, 6 plus 5, 11. So N2, 2 into 8, 16. So N3, 16 minus 11, 5. So number of covalent bonds N3 by 2, that is 5 by 2, 2.5. So here bond order will be 2.5, that is 2.5 bond will be in between N and O. Bond order 2.5. Next is C2. C2. In C2, N1 will be 4 2 ja 8. As you know, valence electron of carbon is 4, so 4 2 ja 8. N2 16. But for C2 you will have to use MOT, because as I said earlier, such type of questions are actually discussed by MOT, and in MOT such type of questions have been discussed, and in MOT you will see bond order of C2 is 2. Its bond order is 2, and here both bonds are of pi nature. Very important question it is, and this is in MOT. So here you learn this, remember this. O2 minus, this is a superoxide ion. O2 minus is peroxide ion, and here OO bond order is 1.5, because here N1 6 2 ja 12 plus 1 13, N2 16, so N3 will be 3, so number of covalent bonds will be 1.5, and He2 plus, again this will be discussed by MOT, and in MOT you will see here bond order comes to be half, that is 0.5. So which of the following option with respect to increasing bond order is correct? So here answer will be 4. You can see here answer will be 4. Any doubt to anyone? But such type of questions will be clearly discussed by MOT, molecular orbital theory. If you will use LDS rule for such questions, so it may be failed in some cases. Next, question number 21. 21. CaO and NaCl have the same crystal structure and approximately the same ionic radii. If U is the lattice energy of NaCl, the approximate lattice energy of CaO will be simple as 4 into U, because you know value of lattice energy, that is U mod, is proportional to charge of cation into charge of anion upon interionic distance, which will depend on the size of ion. Here in this question R naught has been taken almost same, so forget this. So U mod proportional to charge of cation into charge of anion. In NaCl, charge of cation is +1, charge of anion is -1. But in CaO, charge of cation is +2, charge of anion is -2. So in CaO, you can see the charge of cation is also doubled and charge of anion is also doubled. This is doubled, this is also doubled, 2 times, 2 into 2. So lattice energy value of CaO will become 4 times than that of NaCl, and lattice energy of NaCl is U, so lattice energy of CaO will be 4U, 4 times. Clear? टेस्ट में हाईएस्ट कितना गया जरा फाइंड करिए उन बच्चों के नाम. Okay, next 21. After 21, question number 22. Which of the following solid is a typing error, this is solid only. Which of the following solid have highest value of Kp when heated in closed vessel? Listen, as you know, this question has also been discussed in the video lecture. Thermal stability. Thermal stability of metal carbonate will be inversely proportional to its Kp value, right? Now look here, sodium carbonate, you know, sodium carbonate is thermally highly stable and it does not decompose to give CO2 gas. On heating it melts but does not decompose. So sodium carbonate, forget it, it can't be the answer. Now carbonate, same, lithium plus, Be2 plus, Ba2 plus. In between Li plus and Be2 plus, Be2 plus has more charge. And in between Be2 plus and Ba2 plus, Be2 plus is smaller. So among these cations you can see Be2 plus is smallest in size and has +2 charge also. And as you know, more the charge on the cation, more will be its charge density, more will be its polarization power, and therefore less will be the thermal stability of its carbonate. What I said? More the polarization power of cation, less will be the thermal stability of its carbonate. Therefore, among these carbonate, beryllium 2 plus has highest polarization power, and therefore among these carbonates, beryllium carbonate BeCO3 least stable, least thermally stable. Since least stable, so beryllium carbonate, it is solid ionic compound. On heating, it will decompose to give beryllium oxide solid plus CO2 gas. But since vessel is closed, so no CO2 gas will escape into the atmosphere. Since vessel is closed, so CO2 gas will remain inside the vessel and will start building up pressure inside the vessel, and after some time equilibrium will get approached. If in a reaction one of the products is gas and such reaction is carried out in closed vessel, then such reaction will never go to completion, but equilibrium will be established here. So equilibrium will get here. Now you can see Kp will be partial pressure of this, but this is solid, so its partial pressure will be 1. Partial pressure of CO2 gas upon partial pressure of this, but this is also solid, so 1. So Kp is equal to partial pressure of CO2. Now you can see among these carbonates, this is least stable, so lesser the stability of the carbonate, more will be its tendency to liberate CO2 gas. So it will give more CO2 gas, more CO2, more mole of CO2, to higher Kp value of BeCO3. So here BeCO3 is least thermally stable, so highest Kp value at the same temperature. Got it? Got it? Next, question number 23. Type of bonds between calcium and carbon in CaC2. Look here, CaC2, this is calcium carbide. Calcium metal, this is non-metal, C2 has 2 minus, calcium has 2 plus, and in between plus and minus there will be ionic bond. There will be covalent bond in between two carbon atoms, because in between non-metal atoms there will be covalent bond. But here in this question it has been asked bond between calcium and C2. So calcium has +2, C2 has -2 charge, and in between plus and minus there exists an ionic bond. So here the answer will be ionic bond 4, right? Next. 24. The correct order of increasing XOX bond angle is. Look here. This is OCl2. O has two lone pair. This is water. And this is OF2. In all these three molecules, hybridization of central atom O is sp3, right? But in OCl2, that is Cl2O, bond angle is highest, almost near to 111 degree, greater than normal tetrahedral angle also, because here the steric repulsion in between two Cl atoms dominates over the lone pair repulsion. So due to steric hindrance in OCl2, its bond angle becomes highest. Now in OH2 and OF2, in water bond angle is near to 104.5 degree, and in OF2 bond angle is near to 102 degree, near to 102 degree. So here the bond angle in OF2 is still lesser than that of water. So highest bond angle is in OCl2 than water, and least bond angle in OF2. In between water and OF2, this can be explained by using Bend's rule, which is in second part of bonding. And here, without using Bend's rule, you can give the answer like this way. Listen, here steric hindrance dominates, so here bond angle is highest, forget it. Here bond angle in OCl2 is highest. But in between water and in OF2, steric hindrance does not dominate here, right? So here you will answer without Bend's rule, you can give answer like this way. Nearer the bond pair to the central atom, greater will be the bond angle. And farther the bond pair from the central atom, lesser will be the bond angle. Remember this. So here you know F is more electronegative than O. So bond pair will remain farther from central atom O. Since here bond pair will remain farther from the central atom, therefore here bond angle will become lesser. And in water you can see O is more electronegative than H, so bond pair will remain nearer to the central atom O, and if bond pair nearer to the central atom, then bond angle will be more. So in water bond angle is more than that of OF2. But in detail, in real sense, such type of questions will be discussed by using Bend's rule, which is in chemical bonding part 2. First watch video. In video I have discussed Bend's rule clearly, and then we will discuss it. Right. Now the next question 25. 25. Nodal planes of pi bonds in CH2 double bond, C double bond, C double bond, CH2. Look here. Such type of question is also in your video lecture, which has been discussed there. This is the question. This is cumulene. Cumulene means cumulenes mean such polyenes. Polyenes means two or more double bonds, compounds having two or more double bonds. Such polyenes in which double bond is in succession. This is cumulene, and in video lecture I have discussed if in cumulene the number of double bond is an odd number, then such molecule will be planar. And if number of double bonds is an even number like 2, 4, 6, 8, then such cumulene will be non-planar. So here you can see number of double bonds is an odd number. So this molecule will be planar. Now look here. This is CH2 and here 2CH. Okay. Now this carbon has 1, 2, 3 sigma, so sp2. This carbon has 2 sigma, so sp hybridization. This carbon also has 2 sigma, sp. This carbon has 3 sigma, so sp2. Okay. Now S and 2p, suppose px and py. Suppose here S, px and py take part in hybridization, form hybrid orbitals and form sigma bond. So pz, px and py of this carbon undergo hybridization. So pz of this carbon is unhybridized. So pz of this carbon will overlap with pz of this carbon, lateral overlapping, and will form pi bond. Now this will overlap with this, so one axis must be same. So if here px, py, so either you will take px or py. Now you can see of this carbon, px orbital takes part in hybridization, pz form pi bond to this side, so py, which is left here, py of it will form pi bond with py of this. So this is spx, here px, so here also px should be there. Now of this carbon you can see px involves in hybridization, py forms pi bond to this side, so pz of it is left. So pz of this carbon and pz of this carbon will form pi bond. Now look this carbon, pz of this carbon forms pi bond. So px and py of this carbon will involve in hybridization, will form sp2 hybrid orbital, which will form sigma bond. So you can see here also px, py, so these CH bonds will be in xy plane. And here also px, py, so these hybrid orbitals, these bonds are in xy plane. Therefore I said this is planar. Now suppose here the molecular plane is xy plane. Here the molecular plane is xy plane, sigma plane. Sigma plane is xy plane. In hybridization, px, py involve. So hybrid orbitals will be in xy plane, and since hybrid orbitals form sigma bond, therefore xy plane will be the sigma plane, will be the molecular plane. Now this pi bond is formed by pz, pz. pz, pz. This is formed by py, py. Again this is formed by pz, pz. Listen, pz, pz means electron of this pi bond will be in Z. Therefore, nodal plane of this pi bond will be perpendicular to the Z plane, that is again in the xy plane, that is molecular plane. So, there are two pz, pz pi bonds. Therefore, nodal plane of these two pi bonds will be in the xy plane, sigma plane, and nodal plane of this pi bond will be perpendicular to the sigma plane. Therefore, the right answer of this question is, find which is the right answer. 2 in molecular plane and 1 in a plane perpendicular to molecular plane which contains carbon-carbon sigma bond, correct? 2. But such type of questions have been discussed in a video lecture. Watch it carefully, it will become clear. Now, 26, move to 26. A metal M forms chlorides in its +2 and +4 oxidation states. Which of the following statement about these chlorides is correct? MCl2 is more ionic than MClO4. Right. It is right. MCl2. Look here. One is MCl2 and one is MCl4. In MCl2, oxidation state of M is +2 and in MCl4 +4. Now, both are same atom. Then, more the charge on the atom, cation, higher the charge on the cation, more will be its charge density and therefore more will be its polarization power, and if more polarization power of the cation, more will be the covalent character in its compound, and so less will be the ionic character in its compound. So MCl4 will have more covalent character, that is less ionic character, and lesser the charge on the cation, lesser will be its charge density, and so lesser will be its polarization power, and therefore lesser will be covalent character in it, and less covalent character, so more ionic character. Therefore option 1 is correct. MCl2 is more ionic than MCl4. Got it? Finally got it. Sujata Das. Thank you. Sivanshu. Got it, got it. Good. Now 27. Move to question number 27. 27 is the decreasing value of bond angle from ammonia to stibine SbH3 down group 15 of the periodic table is. Listen, question number 27 is what? Listen, this question has been discussed in video lecture in the topic Drago rule. Right? Such type of question in case of ammonia, phosphine explained by Drago rule. But here I am not using Drago rule. Without using Drago rule, I am giving the answer. I am explaining this. As you know, Px, Py and Pz, they are orthogonal to one another, each other. In between Px and Py, there will be an angle of 90 degree. In between Py and Pz, there will be an angle of 90 degree. Suppose this is X and this is Y and this is Z axis. So there will be 90 degree, 90 degree, 90 degree. So as in hybrid orbital, P character will increase, the bond angle will become near to 90 degree. The bond pair will, the bond angle will become near to 90 degree. So increasing P orbital character in sp3, the answer will be correct 4, 27-4. Everyone right? 27-4. Because you can see in ammonia, angle is given 106 degree, whatever be. To stibine, it is very near to 91, that is very near to 90 degree. That means on moving down a group, the bond angle becomes nearer to that of 90 degree, and 90 degree angle is in between Px and Py. That means in hybrid orbital, P orbital character is going to increase. P orbital has been increased so much that the hybrid orbital becomes more like that of a pure P orbital, and therefore bond angle is very near to 90 degree, 27-4. Now move to question number 28. The charge by size ratio of a cation determines its polarization power. Which one of the following sequences represents the increasing order of the polarization power of the cationic species? Right? So the real answer here will be 2. Because K plus has less charge, +1 only, and size of K plus is large. So the charge density of K plus is small. But in Be2 plus, Mg2 plus, Ca2 plus, you can see charge is same. But as size of the cation will decrease, charge density will increase, and as charge density will increase, polarization power will increase. So right answer will be 2, 28, 2, because as charge density of the cation will go on increasing, polarization power of the cation will go on decreasing. So question number 28, right answer 2. Next, 29. Amongst LiCl, RbCl, BeCl2 and MgCl2, the compounds with greatest and least ionic character. Greatest ionic character means polarization power of cations should be least and polarizability of anions should be least. Since anions are same in all these examples, therefore only you have to see polarization power of cation, and polarization of power of cation will be least when charge on cation is least and size of cation is large. And here you can see in rubidium chloride, in RbCl, rubidium has +1 charge, and since rubidium is alkali metal, so its size is also very large. So in RbCl you can see the cationic part, that is Rb plus, has very small charge, that is +1, and its size is large. Therefore its charge density is least, polarization power is least. So in RbCl covalent character will be least, and covalent character least, so ionic character will be most. So greatest ionic character will be in RbCl, and least ionic character means most covalent character, and most covalent character will be when polarization power of cation is highest. And here among these you can see beryllium 2 plus, Be2 plus is very small in size and 2 plus charge, more plus charge. Therefore charge density of Be2 plus is very high, so its polarization power is very high. So more polarization power of the cation, more covalent character in its compound, and less ionic character. So in BeCl2 ionic character will be least. So its answer will be 2, 29. Any doubt to anyone? No. Back bonding, Mohit. Back bonding will be discussed in chemical bonding part 2. First, watch the video of back bonding. Then we will discuss about it. Once you watch the video, everything will get clear. Then you will discuss with me. Next, question number 30, the last question. Where is the polarizability of halide ions increases in the order? Very simple question. As you know, larger the size of the anion, more will be its polarizability towards the cation. So polarizability of halide ions increases in the order, so the right answer will be 4. F minus, larger Cl minus, Br minus again larger, I minus again larger, and as size of an ion will get larger and larger, will become larger and larger, their polarizability will increase. So question number 30, answer is 4. Correct? Now, anyone, any doubt? Anyone, any doubt? Or should wind up? Any question to anyone? Back bonding, Mohit, in chemical bonding part 2, it will be discussed. First, watch the video of back bonding. Okay, no doubt to anyone? No doubt? Okay.